Hello dear children, how are you? I hope you all are in the best of your health and enthusiastic towards your studies. Children, today we are going to discuss chapter number 11 of class 8th science, that is force and pressure. So first of all, let us see what we already know. How we decide whether an object is moving faster than other? Why cyclones and storms, they blow away the roofs of the buildings? We know that a moving object can change its direction of motion. We also know that a ball moving on a floor stops after some time. So, let us see what we are going to discuss in this chapter. Force, types of force, what force can do, pressure and atmospheric pressure. We are going to discuss all these topics in detail. So, first of all, let us start with force. What is force? Children, we experience force in our daily life, like when we open or close a door, at the time of cycling, or when we lift something. We need force. But what is this force? Let us imagine that a stationary ball is lying on the ground. Now, if a player push the ball to the other player, he will kick the ball. And when he kicks the ball, means he applied force on it. And the another player will also apply force to either stop the ball or to change the direction of the ball. Let us see one more example. Imagine that we want to change the position of our computer table. For this, you have to push the table from point A to point B. It also shows that you are applying force on the table. Here, pushing is a method for applying force. If you are picking something from the table, it also means that you are applying force on that thing to lift it up. So, dear students, kicking, pushing or lifting the things are the different ways of applying force. In science, a push or a pull on an object is called a force. Interaction of one object with another object results in a force between the two objects. Let us think about the previous example where a player kicks the ball towards another player and the other player stops the ball. Here, interaction occurs between ball and players. In second example, when you push your table from one point to another, you interact with the table. So, dear students, from these examples, we conclude that an interaction of one object with another object results in a force between the two objects. Now, students, let us have a look on the effects of force. Force can change the shape, motion and direction of motion of an object. Inflate a balloon and try to press it. When you blow air in balloon, you will observe a change in its shape. Similarly, an iron plate can be deformed on hammering. From these examples, we can conclude that force can change the shape of the object. Students, if we apply force on a stationary ball, it begins to move. As you must have seen in a football match, that a football lying on ground when kicked begins to move. Here, force can change the position of the object. Force can stop a moving object. For example, when a cricketer catches a ball, it comes to rest. So, force can change a moving object's motion. Similarly, force can change the direction of the moving body. We can change the direction of a ball when we play hockey. Students, force can change the speed of a moving body. For example, if you are cycling and your friend apply force on you, your speed will increase. So, dear students, from these examples, we can conclude that force may make a moving object move from rest, may change the speed of an object if it is moving, may change the direction of motion of an object, and force may bring about the change in the shape of an object. Now, let us learn about types of force. We can see that to apply force, there should be interaction of two objects. But how this interaction occurs? On the basis of interaction of forces, forces can be of two types: contact forces and non-contact forces. First of all, let us discuss contact forces. Contact forces are forces which act only when objects are in physical contact with each other and bring about changes. For example, you are thirsty and there is a glass full of water on the table. To quench your thirst, you have to take the glass up to your mouth. It means you applied force on the glass and took up to your mouth. Your hand is in direct contact with the glass. Therefore, this is a contact force. We have seen in very first example that when you pass the ball to your friend, for that you have to kick the ball. It means your foot will come in contact with the ball. Similarly, when your friend will stop the ball, there will also a contact between his foot and the ball. So, dear students, these forces are contact forces. In these examples, force is applied on the object due to our physical contact with that object. This force is caused by the action of muscles in our body. The force resulting due to the action of muscles is known as muscular force. Animals also make use of muscular force to carry out their physical activities and other tasks. Animals like bullocks, horses, donkeys and camels are used to perform various tasks for us. In performing these tasks by the use of muscular force, since they perform these tasks by the use of muscular force. Since muscular force can be applied only when it is in contact with an object, it is also called a contact force. Dear students, now let us discuss one more contact force, that is frictional force or friction. You must have seen that a ball rolling along the ground gradually slows down and finally comes to rest. When we stop paddling a bicycle, it gradually slows down and finally comes to a stop. So students, here friction is the reason which causes the change in the state of motion of the objects. Here, the force of friction between the surface of the ball and the ground that opposes the motion of the ball brings the moving ball to rest. The force of friction always acts opposite to the direction of motion. Since the force of friction arises due to contact between surfaces, it is also an example of a contact force. Dear students, now let us discuss about some non-contact forces. You must have seen magnets. Take a bar magnet. Place an iron nail near the bar magnet. Now, take the bar magnet near iron nail slowly and take care that the magnet do not touch the iron nail. You will observe that iron nail will move from its original position towards the magnet. What does it mean here? It means here that magnet attracts the iron nail without contact. The force exerted by the magnet is called the magnetic force. Thus, a magnet exerts a force on an iron nail even when they are not in contact. So, the magnetic force is an example of non-contact force. Let us see one more example. Take a ball and throw it in the air. You will see that the ball covers a specific distance and then comes back and fall towards the earth. It is clear that here is a change occurs in the state of motion of the ball. All the objects fall towards earth because it pulls them. This force exerted by the earth on any falling object is called the force of gravity or just gravity. This force is also an example of non-contact force. Now, we will discuss one another non-contact force. Take two balloons and inflate them. Now, hang them in air. Have you seen any force between them? No. Now, hold on one balloon and rub it with a woolen cloth. Now again hang it near to the other balloon. Now you will observe that this balloon attracts other balloon. It means there is a force between these two balloons. Why it happens? This happens because the balloon is said to have acquired electrostatic charge after it has been rubbed with a woolen cloth. So now this balloon becomes a charged body. It attracts the uncharged balloon. Dear students, the force exerted by a charged body on another charged or uncharged body is known as electrostatic force. This force comes into play even when the bodies are not in contact. So, the electrostatic force therefore is another example of a non-contact force. In this way, we have learnt that non-contact forces are of three types: magnetic force, force of gravity, and electrostatic force. Dear students, now let us learn about pressure. What is pressure? When you try to push a nail into a wooden plank or in wall, you hammer it from its head side and its pointed end moves into the wall. If you try to push a nail from its head side, does it will move in the wall? If you do it again and again, then after also the nail will not move into the wall. What is the reason here? Because the pointed end applies more pressure here. Although the force applied on the nail is almost the same in both cases, but this force acted on different areas of contact. The pointed end of a nail has much smaller area of contact than that of its head. Therefore, the effect of force depends on the area of the object on which it acts. So, pressure is the force acting on a unit area of the object. Pressure P is equals to force upon area. P is equals to F by A. The standard unit of measuring force is Newton and area is meter square. Therefore, the standard unit of measuring pressure is Newton per square meter, which is also called Pascal or PA. Pascal unit is named after the name of the famous French scientist Blaise Pascal. Students, pressure is inversely proportional to the area of contact. Inversely proportional means for similar force, smaller the area, larger the pressure, and if larger the area, smaller is the pressure. That is why the nail didn't move in from its head side, because the area of the head side is more than the pointed side, and due to larger area, pressure becomes less. You must have seen that the cutting edges of knives are always sharpened. It is not easy to cut the fruits and vegetables from the blunt side, as there the area is more. Hence, the pressure will decrease. Whereas, if we use sharpened knives, the area of contact decreases. Hence, pressure exerted by them increases and we cut things easily. Students, we consider only those forces which act perpendicular to the surface on which the pressure is to be computed. Let us have one more daily life example. Your school bags? Yes, your school bags has wide straps. Can you tell why? Yes, due to wide straps, the weight of the bag may fall over a larger area of the shoulder, producing less pressure on shoulders, making it more comfortable to carry the heavy school bags. Dear students, now let us learn about pressure exerted by liquids. Liquids exerts pressure on the walls and the base of the container. If we observe a liquid under different layers, many important facts can be revealed. Imagine a bottle, and here we divide the liquid in bottle in 5 layers. You will see that second layer is under the pressure of first layer, third layer is under the pressure of second layer and first layer. Similarly, fourth and fifth layers are under the pressure of the upper layers. So, what we understand from this? It is clear that the lower layer has more pressure than the upper layers. The uppermost layer will have the least pressure and the lowermost layer will have maximum pressure. For this, have a look to this activity. Take an empty bottle and fill it with water. Now, make a hole near the uppermost layer of water. You will see that the water from the uppermost hole will come out. Now, make holes near the lower layers and observe that water is coming from different holes falls at same point. No, water from the lower holes goes farther from the water coming from the upper holes. From this activity, it is proven that pressure increases with depth. Dear students, now we will learn about atmospheric pressure. We know that there is air all around us. This envelope of air is known as the atmosphere. The pressure exerted by this air is known as atmospheric pressure. As the atmospheric air extends up to many kilometers above the surface of the earth, so the magnitude of atmospheric pressure is very high on us. Then why we are not crushed under this weight? Because the pressure inside our bodies is also equal to the atmospheric pressure and cancels the pressure from outside. Dear students, now let us see what we have learnt in this chapter. Force has magnitude as well as direction. A force arises due to the interaction between two objects. Force per unit area is called pressure. Liquids and gases exerts pressure on the walls of the containers. The pressure exerted by air around us is known as atmospheric pressure. Now, let us do some fill-ups. I hope you already have the answers. First, the force exerted by a charged body on a charged or uncharged body is called dash. Yes, you are right. The answer is electrostatic force. Question number 2. Liquid exerts dash on the base of the container. What liquid exerts? Yes, liquid exerts pressure on the base of the container. Third, bullocks use which force to perform their tasks? Absolutely right. Bullocks use muscular force to perform their tasks. Last question. A moving ball stops on its own due to the force of dash. What causes the moving ball to stop after some time? Yes, force of friction, or we can say frictional force can stop a moving ball on its own. So, dear children, here we come to an end of this topic. I hope you all have understood it well. So, you all keep studying, keep smiling and be safe. We will soon meet with a new chapter. Good day.